In the previous video, we looked at what hypothesis testing was, how to find the null hypothesis and alternative, and also what kind of errors could be made. Now we're going to look at how we run the tests. So there's two possible methods of running the test. The first one we're going to look at is, this is method 1. This is using what is called a p-value. Okay, so after determining the null and alternative hypothesis, the next step is to calculate the data summary, or the test statistic, that measures the difference between the sample result and the null value. We then compute a probability called a p-value. This is the probability, so this p-value is the probability that indicates how unusual the computed value of the test statistic would be if the null hypothesis was actually true. So the smaller the p-value, the more likely we are to reject the null. In other words, if we have a very large p-value, then the probability that the null hypothesis is true is probably likely. So we have to decide whether to reject the null hypothesis or not. And to decide this, we're going to use what is called a level of significance. It's going to be a value that we compare our p-value to. If our p-value is smaller than that, then we reject the null hypothesis. If the p-value is bigger, then we fail to reject it. We were saying it's probably true. Okay, so that's how we're going to analyze it. We're going to compare it to this mysterious alpha, and we'll talk about how we get this alpha here in a second. Let me get my next page. So, let's go into a little bit more detail on this. The level of significance is chosen before you start the experiment or the study. The phrase statistically significant is used to describe the results when the researcher has decided that the p-value is small enough to decide in favor of the alternative, that we've rejected the null. We've rejected that the status quo is still the same. So how we find this p-value? The probability of a test statistic as extreme or more extreme than the observed test statistic depend on the direction. So for a less than, we're checking to see if our test statistic is equal or less than what it is. Greater than, we're looking at greater. This is an easier way to look at it. Let's actually look at some pictures. If we're looking at a less than, then our p-value is the probability, or this area right here. This is our p-value. This is a left tail test. Left tail. Our p-value is represented by this area here. So the smaller that is, the more likely we are to reject the null. And if it's a right tail test, we're doing the greater than test. We're looking at the p-value over here. P-value. And if we have a two-tail test, that's that not equal to, it could be here or here. So we're looking at two tails. We're looking at two probabilities. Okay, two tails. Before technology became so widespread, it was difficult or impossible to compute the p-value in many circumstances. So researchers used the method called the rejection region, kind of finding that region that we were just sketching. Is the region of possible values that would lead to rejecting the null hypothesis. Now, using that rejection region, or using the p-value and comparing it to our alpha, both will give you the same results. You'll have equivalent conclusions whichever way. So when we learn the two methods, you'll be able to choose which method works best for you depending on what calculator you use and that type of thing. Now remember, the two conclusions we're going to get. We're either going to reject the null hypothesis or fail to reject the null hypothesis. We never accept the null hypothesis. We reject the null hypothesis in favor of the alternative, or we fail to reject the null hypothesis. Remember, think of a criminal trial. In any trial, the defendant is assumed to be innocent. We give the defendant the benefit of the doubt. The district attorney must collect and present evidence and prove the defendant is guilty beyond a reasonable doubt. Because we are seeking evidence for guilt, it becomes the alternative hypothesis. Innocence is assumed. That's the null hypothesis. So the null is that you're innocent. The defendant is innocent. The alternative is that you're guilty. The trial is us collecting that data. When we're deliberating, we're really doing our data analysis. When the jury comes back with our conviction, it's either rejecting the null hypothesis, we're convicting them, or declaring them not guilty, failing to reject the hypothesis. Note, you never declare them innocent. You ever notice that? They never declare them innocent. They either say they're not guilty or that they are guilty, but never declared innocent. We can never conclude the null hypothesis is true. We either reject it or we fail to reject it.